transformations. In this video, I want us to see how to transform the trigonometric functions. So I'll just do some few examples. But before I do those examples, let me start with the general form of the transformation of the graph of this graph. So let's say we are given y is equal to a sine x plus p plus q. We know that our basic graph of sine is y is equal to sine x. It's just sine x, y is equal to sine x. But we have made some transformations of adding another value here as well as that other value. So the transformations that we have is either we have translation, we have reflection, those two. That's what I want us to see. So let's start by translation. When you're saying you're translating a graph, it means we are taking it from one position to another without changing the shape of that graph. We just shift it either up or down, left or right. So let's see which one between P and Q represents the left translation or right translation, as well as upwards translation or downwards translation. So let's start by P. Value P, it represents left or right shift. In other words, we can call it horizontal shift, left or right. Then when P is greater than 0, it represents shift to the left. Then when P is less than 0, it represents shift to the right. When I say P is greater than 0, I'm just trying to say P is positive. When P is less than 0, P is negative. So if you see a negative P here, it means your graph is being translated P units to the right. If it is positive, P units to the left. For example, let's say we're given f of x is equal to sine x plus 30 degrees. This one, it means the graph is being shifted 30 units, 30 degrees to the left. Then f of x, let me use g of x, is equal to sine, or in this case, let me use cos. So using cos, these things for cos and sine, even for tan, it's just the same thing. You use the same method. So I'm gonna use all different graphs so that you can understand how to use it on all the three graphs. So this is for cos x minus, let me say 20 degrees. This shows us we have shifted our basic graph, which is cos x, 20 units to the right, 20 degrees to the right. So 20 degrees to the right. That's what it means. Then now, let's go for Q. We want to see what does Q represent. This Q, it represents up or left, up or down shift. Upwards or downwards shift, or you can say upwards or downwards shift or translation. So for positive Q, others can say Q greater than 0. It means translation upwards. Then for negative Q, this is translation downwards. So for Q, the sign that it here shows you the direction. For positive, we know positive y-axis is up. So if it is positive q, it shows you that it's being translated up. The only difference is on horizontal shift. If p is negative, yes, we know the right side is the positive, but in this case, it is the opposite one. You go to the left. So that's what P and Q represents. It's just the transformations. Then let's see this value of A. If value of A increases, what happens? So if A increases, the amplitude of the graph will also increase. When we talk of amplitude, we mean sine graph and cosine graph. Because you know tan graph doesn't have the amplitude, it's not applicable. So if A increases, the amplitude of sine and cos graph increases. So let's have an example. Reflection. So here I want us to see how the graphs are being reflected. So we only want to cover one type of reflection. A reflection, which is a reflection across the x-axis. So this is how to do it as an example. E.g., reflect the graph. Let me say the graph of function f of x is equal to cos x to form g of x. So if we are reflecting across the x-axis, what we just have to do is to say g of x is equal to negative f of x. You are multiplying the whole function of f with the negative. So this is going to be minus multiplied by cos x. This will give us negative cos x as our reflected graph. So what it means graphically, we know the basic graph of course is like this. We have 1 minus 1, then here we have 90, 180, 270, and 360. So it is like this. That's the graph for cos x. So let me label it graph f. Now I want us to reflect it. So if it is reflected across the x-axis, our graph will look like this. We are using this x-axis as our mirror line. So meaning what we see here, you will see it will be reflected this side. This one will be also reflected that side. So our new graph, this point is reflected this side, then it starts here, going up, then it turns, then back. So this is our reflected graph, which is for G. So this is our reflected graph. Let's say we're given a function h of x is equal to negative cos x plus 1. Then say reflect this graph to form, maybe it's a k of x. So we know k of x will be negative h. It will be negative h of x like this. Then our new graph will be minus multiplied by negative cos x plus 1. Then by simplifying it, minus and a minus gives us a positive. So our new graph will be cos x minus a 1. That will be our k of x.